Hi guys, welcome back to another Math with Mitchell video, and we're going to be going over how to find the determinant of a matrix. So this is pretty important in finding inverses and using different properties of matrices in equations. But in this video, we're just going to go over how to find the number and some special, and we're actually going to go over two methods of finding it, one for 2 by 2 and one for 3 by 3. Before we start, I want to also point out that in order to find the determinant of a matrix, the matrix, the number of rows has to equal the number of columns. So usually divided by n. So the rows have to equal the columns. This is a pretty important thing and is a requirement in order to find the determinant. So most of the time, you're only going to be dealing in Algebra 2 with 2 by 2s and 3 by 3s. So we'll go over two methods of finding those determinants. Now later in linear algebra, you'll be going over multiple different methods of finding the determinant, but all you'll need to worry about is the two that I will show you here in this video. So first, for 2 by 2. As you can see, I already put the general equation to find a determinant of a matrix for a 2 by 2, and that's by taking A times D and subtracting it by B times C. So in our example here, we have A. So if we wanted to find the determinant, of A, then it would equal to -2 times 5 subtracted by 1 times -3, which in this case would equal to 13. So the determinant of this 2 by 2 matrix is going to equal to 13. Since the rows and the columns are the same, we can find the determinant. Now 3 by 3 is a little different. It's not going to be it's using the same principle as this by taking this diagonal subtracted by this diagonal. But instead, we have to double the first two rows or first two columns. So to find a determinant of 3 by 3, which in Algebra 2 you won't have to do very often, but if you do, you have to repeat the first two columns. So that's what I'm going to do right here. 1 and 2. So I repeated the first two columns, and now what we're going to do is take this diagonal and multiply those terms together, add it to this diagonal, and then multiply those terms together and add it to this diagonal. And then subtract these terms multiplied together, added to this diagonal, and then multiply or added to the multiplication of these terms in this diagonal. So I know it seems a little complicated, but we'll work through it here. So the first set of diagonals is going to be 2 times 1 times 1 plus -4 times 3 times 6 plus, remember to keep track of your signs here. It's one thing that gets tricky. 6 times 5 times 2. So that's going to be the first diagonal. And note that it's the same direction as the original equation here. Like it's this diagonal and then subtracted by that diagonal. So then you're going to subtract all the terms in the next diagonal, which would be 6 times 1 times 6. Sorry. 6 plus 2 times 3 times 2 plus -4 times 5 times 1. So then ultimately this will come down to equaling so that would be, the first thing is going to be 2 plus -72, right? Yeah, -72 plus plus 60. So then this is going to, or then this is all subtracted by the next set, which is going to be 36 plus 12 plus -20. So then if we simplify this again, we get, and then we add these terms together, and we get -10 subtracted by, let's see here, 28. Wait. Let me double check. Yeah, 28. So then that equals -38. So the determinant for this 3 by 3 is going to be -38. So I know that's kind of extensive, but it's the best technique for using or one of the easier to understand techniques for 3 by 3. Just the biggest thing to remember is that the rows have to equal the columns,